Hello, everyone, and welcome to another Mini Sky Tonight. So we're getting towards the end of our solar system tour, and we're looking at the two twin planets, Uranus and Neptune. Now, we don't know a lot about these different planets because we've only visited them with one particular spacecraft, Voyager 2, but we have taken different images from these different planets. So let's take a look into Uranus and what we do know and what we hope to know in the future. So Uranus is named after the Roman god of the sky, who was the grandfather of Zeus. But it was named after the Roman god because it was first discovered by William Herschel in 1781. Now we're getting into these two particular planets that weren't discovered until much later. Many of the planets I've discussed prior have been known throughout the centuries, whereas in Uranus and Neptune weren't discovered until the 17th and 18th centuries, respectively. So these are relatively, quote unquote, new planets. Even though it was first observed by Hipparchus in 128 BC, he thought it was a star. In fact, he thought it was at the time it was in Taurus, and he thought it was the 34th star of Taurus. So he wasn't quite sure. In fact, other astronomers have come across these particular planets, but they thought they were just faint stars. And as you can see in the image here, it does kind of look like a faint star. And because it takes so long for it to orbit around the sun, it doesn't move very fast. So within the course of at most a month, it would only maybe move a little bit. So even Herschel, when he first discovered it, he thought it was a comet because it wasn't a part of any known star system. And it looked like it was next to a star that was well known. So he did some more research on it. And with other observations from different sources that they could confirm it wasn't not a comet, it was accepted in 1783 to be another planet. And at first they were going to call it the planet after Herschel himself, but they wanted to keep in context with the other planets. So they named it Uranus after the Roman god. So 1 year on Uranus, it takes 84 years to go around the sun once for Uranus because it's that far away. It's 1.78 billion miles away from the sun. So it's quite a long distance away. So it takes quite a fast traveling to be able to get through its distance around the sun. And like the other gas giants, it rotates relatively fast for its size. 1 day on Uranus is 17 hours. So just a little shorter than our 24 hours here on Earth. And this image here kind of gives you a size comparison of Earth with Uranus. It's not that big. Many people think it's always this huge, gigantic gas giant, when in actuality, they're not that big. It would be like comparing a basketball to, if the Uranus was a softball, Earth would be a nickel. That's how the size comparison would be. It's not that big, but it's incredibly cold. In fact, sometimes it can be known as the coldest planet in our solar system because it has temperatures at negative 350 degrees Fahrenheit, and it rotates clockwise, kind of like Venus, who has a rotation in the opposite direction of the other planets. The sun would appear to rise in the west and set in the east. But what makes Uranus so unique is that it's tipped on its size. It has a 97-degree tilt. Here on Earth, we have a 23.5-degree tilt. Uranus is like this. So its North Pole is practically pointing at 90 on its side. It has 27 known moons. It could have more, but we don't know. And many of those moons are named after Shakespearean characters in many of his plays. Like there's a moon called Puck from Midsummer Night's Dream and many other different plays. This is the first time that they basically broke the mold when it comes to naming different celestial objects. They decided to name it after Shakespearean characters. It has a magnitude of 5.7, so it's really faint. So as you can tell, it's unable to see with the human eye. So hence why when it was first discovered, it was discovered by a telescope. But it also has extreme seasons. Since it has that 97-degree tilt, it has incredibly long seasons. The points in time, so like if this is the sun and here's Uranus with its 97-degree tilt, this part of the year, it would be 21 years of summer, 21 years of fall, 21 years of winter, 21 years of spring, and then back to summer. So it has extreme seasons. And sometimes during those 21 years of summer, the sun never sets. And during those 21 years of winter, the sun never rises. So it's crazy of what happens on this planet if you could see those different seasons. So let's dive deep into Uranus for what we know. It does have potentially 3 layers. It has an upper atmosphere, probably an ice and metallic core, but we don't know. The only spacecraft to ever visit it was Voyager 2, and it was able to take some good images of it, but nothing really too in-depth. So we're hoping sometime in the future we're able to send spacecraft to be able to study these unique blue planets a little further. So it has a low heat flux. So what do I mean by that? Well, when we talked about Jupiter and Saturn a while back, as the pressure inside the planet increases, the temperature increases. But for the case of Uranus, the temperature doesn't increase that much. So hence why sometimes it's called the coldest planet in our solar system. And also what makes Uranus and Neptune, and I'll describe that sometime in the future, they have peculiar magnetic fields. Now, as I mentioned, the tilt of Uranus is 97 degrees. Its magnetic field is 53 degrees from that. Oh, forgive me, 59 degrees. So like if you had the actual tilt at 90 degrees, at 59 degrees, that's where the pole would be. And astronomers are baffled as to why this could be. Now, for like here on Earth, the magnetic north and the North Pole are relatively close together. They're just maybe about 0.1 degree off of each other. But in this particular case, having something that's close to 59 degrees away from the North Pole, in the case of Uranus, that would be like having magnetic north in the middle of Texas, in the case of Earth. So you have the North Pole and the magnetic north would be located somewhere in the middle of Texas. And astronomers are baffled as to why. Because usually with a magnetic field, most magnetic fields are created by the rotation of the core. And usually that rotation of the core follows along with the rotation of the planet itself. So astronomers are thinking that either the core is rotating in a different direction than the planet itself. They're not sure how that could be because it would break some of the laws of conservation of angular momentum. And or it could be that the combination of ammonia and methane and everything in its upper atmosphere is causing unique eddy currents inside the planet to give it its unique magnetic field. We don't know. We're hoping by sending a couple of spacecraft with magnetometers, we could find out some of that mystery. Its atmosphere is mostly composed of hydrogen, helium, and ammonia, and definitely strong amounts of methane. Methane and the ammonia is what gives it its deep blue color. So what's happening, what gives it its deep blue color is that since there's so much methane, methane absorbs red light. So our sun produces white light, and white light is composed of all the colors of the rainbow: red, blue, green, orange, and violet. But once it goes through methane, all the colors get reflected back easily, but red light gets absorbed. So we're seeing more of the blue shift as some of the bluer colors, as some of the red colors start to get absorbed. So red, orange, and yellow start to mostly get absorbed, whereas in many of the bluer colors start to easily reflect. So hence why Uranus and Neptune have these deep blue colors. And we see occasional storms on Uranus, but not as prominent as, say, Jupiter or Saturn. Going back to this image, you can see it does have a ring. All the gas giants have rings. This particular ring system is incredibly faint. In fact, it took some false color imaging to be able to see the rings of Uranus because they are composed of darker material. So who's gone and visited this lonely planet? Well, Voyager 1 was planned to go visit it, but it didn't make it. As I mentioned in my Saturn video, it didn't make it because it had some failures in its electronic systems. And so it had to stay around and orbit around Saturn. So the one that did make it was Voyager 2. And it was the only one to be able to visit and study the planet in any type of detail. Hubble has been able to take a fewer images of the planet, including some of its storms and everything, but it's from a distance. And that's the best we've gone. But it's come where you do have some proposals that hopefully within the next 5 years, these will be heading out towards the bright blue planet. We have MUSE, which is if I recall correctly, it's an acronym for basically Uranus, a space explorer. Basically, it's going to study Uranus in a different light. Oceanus, which basically is going to be the next one, because as I was talking in another video on Neptune, Neptune was supposed to be called Oceanus at one point, but they decided to go with Neptune instead. Odinus, which is also another one, as well as the Uranus orbiter probe have been proposed, and they are in the works, but it's hoping in the future that it will be able to get off the ground floor and actually onto a spacecraft to be sent into space. So here's hoping. So where can you see it? If you have a good quality telescope. Now keep in mind, you can't see this with binoculars. It's incredibly faint to see with a pair of binoculars. You have to have a nice, clear, moonless night. And make sure that you're far away from city lights because it's incredibly difficult to see. So what you'll have to do is look towards the west shortly after sunset, and right in between the constellations of Cetus and Andromeda, there'll be a little faint blue star. In fact, if you have an app on your phone that helps you be able to navigate the night sky with, I recommend using it when you're trying to look for Uranus. As I mentioned, it's difficult to find. Hence why it wasn't until the 1700s that it was first originally discovered. So if you have the time and you have the patience and you want to go hunting for this faint little blue star, I highly recommend checking it out on a nice, clear, moonless night with a good quality telescope. If you have any questions or comments, leave it down in the comments below. If there's a topic you would love for me to cover over, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.